Hi everyone, welcome to the class guys. Please confirm once that am I audible to you or not. Hi, good morning Itanago. Okay, so in the previous class we have done with the solid states and soon I'll share the assignment as well with you. Okay. Hi Shillong. So let's start with the new chapter of the physical chemistry, which is the chemical kinetics. Totally numerical based chapter, and again you will find two questions from this chapter, at least two questions from this chapter. Okay. Yes, not too difficult to solve these questions, but yes, the thing is, if you're clear with the concept, then you can easily do such type of questions. Okay. So let's start with the chemical kinetics. Chemical kinetics. Ultimately, what we have to discuss in this chapter. See, till now we know that the chemical reaction occurs, okay, but the question is that how fast they can occur, okay, what should be rate associated to them. Can we predict that if reaction starts at t equal to 0, then what should be the status of the product and the reactant after 10 minutes, or we can say 20 seconds or 10 seconds or 2 hours, or we can say 1 year or 100 years. Okay. So all those changes about the chemical reactions with respect to the time is we have to discuss in this chapter, and how we can categorize the reactions into different parts, or what are the factors that can affect the rate of reaction. Okay. So there are many things that we have to discuss in this current chapter, and ultimately the main aim is to study about the about the rate of the chemical reaction and their status. Ultimately, rate is nothing but the change in the concentration with respect to the time. Okay, that's what we have to discuss in this chapter. So let's start with this one. First of all, it is your branch of chemistry which deals with study of reaction rates and their mechanism. Now, if we talk about rate, we can simply say rate of chemical reaction that it is nothing but change in concentration upon time taken. This is the rate of chemical reaction. Copy please. Done. Now, if we talk about the units, see, first one is for aqueous phase. So for the aqueous phase, obviously we need to consider the concentration. So in the numerator part, we were having the concentration, which has the unit of mole per liter. Okay. Then time. Okay. So we can say that it is mole liter inverse time inverse. See, I am not putting any value of the time, but if we talk about the SI unit, we will simply put the seconds. Okay. But here the unit of time can be anything: seconds, minutes, hours, days, years, anything. Okay. So we have to deal accordingly, whatever is mentioned in the problems. So it can be your second, minute, hours, days, etc. Okay. Next, for gaseous phase. For the gaseous phase, I cannot use the concentration. I have to use the pressure. So its unit will be according to the formula, that is change in pressure upon time. Okay. So for this one unit will be atmospheric pressure, which is ATM time inverse. Okay. So these are the units that you will see in this chapter. Copy. Now, look at this. I am considering one reaction. Look at this. This is example number 1. I am saying that reactant R is getting converted into product P. Okay. Now try to understand it. I can say one thing, that reactant with the passage of time means the value of the reactant or the amount of the reactant with the passage of time will be decreasing, whereas the amount of product with the passage, or we can say that with the time, will be increasing. Okay. So first of all, I would like to write the rate of disappearance of R. What can I say? D stands for the change. Square brackets are representing the concentration. Remember, we have to put the square brackets, and this one is changing with the time. So I'll put the dt. Remember, D is representing the change. Now we are saying that R is disappearing. Therefore, I'll put a negative sign. This negative sign shows that it is decreasing with the passage of time. That's it. If I say rate of appearance of P, what can I say? With the positive sign. See, right now I'm using the word disappearing and the appearance. Later on we will not use any such words, we will simply use the symbols. Okay. dP upon dt. This is how I can write the rate for the reactant and the product. Please copy it. Okay. Now, can I say one thing? That rate of reaction should be equals to minus dr upon dt. Remember one thing, these are not the mathematical negative and positive, these are just a representation. Please keep in mind, these are the representation which is representing decreasing and the increasing values. That's it. Okay. Plus dp by dt. Can I say that? Is it true? Guys, now stop writing, just look at your screen and try to understand. Can I say that? Is it true that rate of reaction should be equals to minus dr by dt is equals to dp by dt? Will it be true? Okay, obviously this is true. Yes, this is true. Why? See, reactant and product are exactly having single species as well as their moles are exactly one. Okay. So what can I say that as the amount of reactant will decrease, with respect to that the same amount of product will be forming. Okay. So what can I say that the amount of product is totally dependent on the reactant, and just because they are having the same stoichiometric coefficient, if I am saying that the 2 moles of reactants are consuming, so definitely 2 moles of product will be forming. If 10 moles are consuming, it means that 10 moles will be forming. Okay. So this is absolutely true that as the amount of reactant is decreased, with the same rate amount of product will be formed. So it is just saying that the rate by which reactant is getting decreased, with the same rate the product will be formed. Okay. So this is absolutely true. Now let's take another example. I am saying A plus B is giving us C. Now I would like to write this one. Rate of reaction. Now one thing, that formation of C is totally dependent on A as well as B. So obviously in proportion to A, the same amount of B should be consumed, and as well as with respect to the B, same amount of A should be consumed, and with the reference of, we can say, with respect to these two, the same amount of product will be formed. So actually I would like to write this one, that minus dA by dt, minus sign is again representing the amounts of reactants, or not amounts, rates of reactant, minus dB by dt should be equals to plus dC by dt. Is it correct? Any doubt about it? Okay. Okay, please raise your hand those who are having the doubt in this one. Shillong. Okay, cool. Let's move on. Okay, Itanagar. Itanagar, I was just saying that as the amount of A will be consumed, so the same amount of B will be used for the formation of C. Okay. So obviously the rate by which A is decreasing, with the same rate B should be decreased for the formation of C. Ultimately C, it's totally dependent on A and B. Okay. So for the formation of C, with the same rate A and B should be consumed, and with the same rate C should be formed. Only that I was saying. Now got it? Welcome. Now let's take another example. This is the general reaction actually. A, B giving C plus P, or we can say let's consider it as a X. Okay, this is a general reaction. Guys, remember one thing, whenever we have to write the rates, okay, we will always talk about for the 1 moles. 1 moles, or we can say for the 1 molecules. Okay, so similarly here as well I'll talk about the 1 moles. Okay, but the problem is the coefficients are given to us. Okay, so I'll convert them. For that, what I will do, just look at your screen, what you have to do for the rate. For the A, I'll simply say it is dA by dt. What you have to do, simply write the coefficient like this, 1 upon whatever coefficient is, okay, because I'm comparing that for exactly with respect to 1 mole of A, how many moles of B should be used, how many moles of C will be formed, and how many moles of X will be formed. Okay, so I have to keep the proportions exactly same. Okay, so I'm just converting it, that's it. And for that conversion, what can we do? We have to simply reciprocate the coefficient given to us. Okay, so here the coefficient of A was small a, so I have simply make it as 1 by A. Similarly for the B, I can write it, it is minus 1 by B dB upon dt. For the product, I'll say it is plus 1 by small c dc by dt is equals to plus 1 by x dx by x. Sorry, dx by dt. I hope so this one is clear to everyone. Please copy it. Okay, and after copying that, you have to write the rate of reaction expression for this one. That H2 plus half of O2 is giving you H2O first, second, twice of HI is giving H2 plus I2. Please write it. Write the rate law expression. Not rate law, simply rate of. Please confirm once, once you have done the question. Okay, so let's solve this. I'm writing the answer. Please cross check once. For the first part, rate of reaction would be minus GH2 by dt is equals to minus twice of DO2 by dt is equals to plus DH2 by dt. For the second part, this is minus 1 by 2 HI upon dt dH2 by dt is equals to di2 by dt. How many of you has done the same? Okay, good. Okay, so let's solve one question. That 10 moles of N2 becomes 8 moles in 10 minutes. On reaction with H2. To form ammonia. Determine rate of disappearance of H2 and rate of formation of ammonia. Reaction is N2 plus 3H2 is giving you twice of NH3. Attempt it. Done? Okay, let's see. I can write rate of reaction as minus dN2 by dt minus 1 by 3 dH2 by dt plus 1 by 2 dNS3 by dt. Okay. So as they all are equal and I have to determine the value of dH2 by dt along with the dNS3 by dt. So first of all, I'll pair up dN2 by dt with H2, means rates of N2 and H2. Okay. Here you can see both are having the negative signs, so they will be simply cancelled out. Our question is saying the 10 mole becomes the 8 moles. Okay. So we know that change we can calculate by simply putting the final value minus initial value. So final value was 8. This sign will get cancelled out. Initial moles were 10, and for the whole process 10 minutes were taken, and is equals to what? 1 by 3 dH2 by dt. So this is minus 2 by 10, which is minus 1 by 5 into 3 is equals to dH2 by dt. Now you can see one thing, that we know that hydrogen is reactant there, so by default we are getting a negative sign. Okay. So I'll have dH2 by dt is equals to minus of 0.6 mole per liter minute. So this is the rate for the H2. Similarly, now I can calculate the rate of ammonia as well. So now I have a choice. Either I can use the value of dH2 by dt, or I can use the dN2 by dt. Okay. So I'm going to use dN2 by dt, which is minus 8 minus 10 upon 10 is equals to 1 by 2 dNS3 by dt. Now you can see by default you will get the positive sign. This is 1 by 5 with positive. 1 by 5 into 2 is equals to dNS3 by dt. So the answer for this one will be 0.4. How many of you has got the same answers? Okay, this was the first question. Copy and then I'll give you the another one. Copied. Okay, do this question. NO2 is forming at the rate of 0.0072 mole per liter per second at a certain time. As given in the following reaction. Determine first rate of change of O2 at the same time rate of change of N2O5 at the same time, next rate of reaction at the same time. Solve. Confirm once when you have done with this. Okay, 2 more minutes for this question. Some students are still trying. Okay, I have asked them for the 2 minutes. They are saying they need 5 minutes. Itanaga, have you done that? Okay. Okay, let's start. Guys, just look at your screen. First of all, you have to write the rate. I can say it is nothing but minus 1 by 2 dN2O5 upon dt is equals to 1 by 4 dNO2 by dt is equals to dO2 by dt. Okay. Actually, in the question, they have already provided you the rate. Okay. So first of all, I have to calculate the rate of change of O2. So rate of O2, I can say this is nothing but 1 by 4 into 0.0072. So this one is 0.0018. Next is rate of N2O5. This is nothing but I can say this is nothing but minus 1 by 2 dN2O5 upon dt is equals to 1 by 4, or I can simply put it as equals to dO2 by dt, because I have just calculated that. So this is 2 into 0.0018, so nothing but 0.0036. Last is rate of reaction. So rate of reaction can be equal to N2O5, NO2 or O2. So I have calculated the O2, so I'll use that. So these are the answers. So now tell me, how many of you has got the same answers? Okay, Annie has got the correct answer. Other than that, okay, might be Amika. Then is Balajit there? Who has raised his hand? Okay, good. What about you? Priyanka, Nafi, then Paul, I guess, Farmwell. Is Daisy also there? Okay, cool. So guys, this is how we can calculate the rate of reaction. Okay. So now let's continue. Types of rate. See, rates can be of two types. First one is your average rate and second one is your instantaneous rate. Okay. So let's start with this one. First one is your average rate. Okay. Average rate is actually been calculated within a finite interval of time, where I'll have the different concentrations in a given particular range of time. Okay. So what can we say that rate, you can copy this one with me, measured over a finite interval of time, and it is obtained by knowing the concentration of substance at two different times. Okay, copy please. And yes, we can use the formula for the average rate, that is plus minus CT2 minus CT1 upon T2 minus T1. Okay, this is the formula. I'll show it graphically as well. See, plus minus is simply representing the reactant and product. Okay. For the reactant, I'll use the negative sign, and for the products, I'll use the positive sign. That's it. Done. Now look at this. This is a graph for the reactant. It is gradually decreasing. Here concentration and here time. I can say that I have to measure the rate here. This is C1 and this is your C2. This is your T2 and this is your one second. Guys, have you copied the formula? Look at this. Have you copied formula for this one? Okay, let's plot the graph. This is your C1 C2, T1, T2. So for this, this is showing the reactant. I can say that average rate would be C2 minus C1 with negative sign upon T2 minus T1. Okay. We can practice a question as well based on this one. Copy this one first. Guys, one thing, make this one as a C2 and this one as a C1. Make upper one as a C1 and this one as C2. Okay. Now, have you copied that? Okay, so next type is instantaneous rate. Is there any confusion in the previous graph? Can we continue with the next rate of reaction? I mean next type? Okay, instantaneous rate. This one is calculated on a particular instance of time at any particular time. Okay, there is no interval exist in this case, so we can say that rate measured at a particular instant and it is obtained by drawing the tangent, few mathematical terms, at that time in the given graph. Okay, look at this. Let's suppose this is your reactant, curve for the reactant. Okay. And I would like to calculate the rate on this point. Okay. So this point I am calculating the rate. So this one is representing the instantaneous rate. Okay. And this is equals to dc upon dt. This is your concentration, this is your time. Please copy. Done? Okay. Next is factors affecting rate of reaction. So rate of reaction depends on many factors, and these are, first one is nature of reactant and product. Next, concentration of reactant. And yes, pressure as well as volume. Next, temperature. Then catalyst. Then effect of sunlight. You can say UV rays. These are actually very important. Next is pH of medium. This is normally for the acid-base reaction only. Normally for acid-base reaction. Please copy. Copy and then confirm. Okay, so let's start with nature of reactant and product. First one is your physical state of reactant and product. You have to remember that rate of reaction is highest in the gases, then liquids, and slowest in the solids. Okay. If we talk about the rate, we can say that gases can react fastest, then liquids and solids will react, or we can say their rates will be the slowest among all these. Other than that, rate of reaction is much more faster for homogeneous reactant and product than as we compared with the heterogeneous. Okay. Rate of homo is higher than the rate of hetero. Then next is surface area of reactant. Obviously, we know that if surface area increases, the active sites for the reaction will be increased. So, with increase in surface area, rate of reaction also increases. Okay. So, we can say that on increasing surface area, rate of reaction increases. Copy this. If you are not clear with any of these points, you can ask me. If you need some more clarification regarding any point, you are most welcome. Okay, so let's move on. See, chemical nature of reactant and product. See, rate of reaction. Obviously, if reactant is unstable, it means its reactivity will be very high, and reactivity high means rate will be high. Okay. So, what can I say, that for the reactant it is inversely proportional. Stability of reactant. Remember, ultimately we are looking for the products. Okay. So, if reactants are unstable, it means we will have much more products. So, rate will be fast, or we can say rate will be high. If we talk about the product should be stable. Okay. So, we can say that it is directly proportional to the stability of product. Ultimately, rate means we are looking for the product. So, if product is stable, it won't be reactive. Okay. So, again the rate will be high. Done? Okay. So, next one is your concentration of reactant. First is concentration is directly proportional, or we can say concentration is nothing but what? N by P. So, what can I say, that concentration is inversely proportional to the volume. So if concentration is increased, we know that rate is nothing but change in concentration upon my time taken. So what can I say, that if concentration is increased, rate will also increase. If we say volume is increased, volume varies inversely with the concentration. So obviously if volume is increased, it means that concentration will decrease. It means rate will decrease. Are you clear with this one? Because volume varies inversely with the concentration. Next, B, pressure. Means this time we are talking about the gaseous reaction. We know that PV is equals to nRT. So P can be N by V RT. So what can I say, that pressure varies directly with the concentration. Same effect will be observed. Okay. See, if concentration is increased, rate will increase. Okay. If pressure is increased, it means again rate will be increased. Please copy. Okay. Done? Okay, so let's take a break of 5 minutes. Okay, refresh yourself and then we'll continue. Sharp 5 minutes. Hi everyone, welcome back. Guys, settle on fast. Okay, so now let's start with the rate law expression. Okay, so let's consider a reaction A plus B is giving us some products. Okay, so now we have to write the rate for this one. See, rate is simply says that it is the product of concentration of reacting species only. There is no involvement of the products for the expression of the rate law. So what can I say, that rate of this particular reaction can be written as concentration of A and concentration of B, having some powers, and these powers are M and N. Now the point is, I am not mentioning the coefficients A and B. Remember guys, here the M and N are the order of reaction, these are not the coefficients. But yes, it is possible that sometimes these coefficients might be equal to this value of M and N. Okay, but these are not necessarily that these should be equal. Okay, so while we have to write the rate law for any chemical reaction, I have to say it is the product of concentration of reacting species. Okay, so this is the rate for this reaction. Now I have to remove this proportionality sign and I'll put a constant K here, and this is your concentration of A having power M, concentration of B having power N. Here the K is your rate constant. Copy this one first. Done? Okay, let's move on. Now, order of reaction. So ultimately, in the rate law expression, we have to study about the rate constant and then order of reaction. Okay, so we'll discuss about the rate constant later on. First of all, we have to discuss about the order of reaction. Okay, so how can we define the order of reaction? It is nothing but it is the powers which we are using in the rate law expression. These are the powers of the concentration of the reacting species. Okay, so we can say that it is the sum of powers of concentration of reacting species in rate law expression. Okay, here if I ask you about the order with respect to A, the power was M, therefore the order I'll write as a M for the A. Order with respect to B, I'll say it is N. But if I ask you about the overall order of reaction, overall order of reaction, I'll say it is M plus N. Okay, copy please. Confirm once. Okay. So I hope so there is no doubt till now. Okay. So let's move on. Some important points regarding order of reaction. First, order of reaction is determined experimentally. Guys, remember one thing. Whenever we classify some reactions, that whether it is the part of the zero order, first order, second order, third order, they all are designed, or we can say they all are defined on the basis of the experiments. Okay, they all have been proven by the help of experiments. Theoretically, we cannot judge any reaction. It might be possible that a chemical reaction which looks like a first order reaction, but it might be of second order, it might be of zero order, it might be of third order. Okay. So order of reaction can never be judged, or we can say that can never be, we cannot get any information just by seeing a chemical reaction. Okay. It is always explained, and it is always determined experimentally. That's what you have to remember. Okay. Next, order of reaction can be positive, negative, zero, or fractional. Order of reaction more than 3 is generally rare. Okay, please copy. Done. Number 4, in rate law expression, order of reaction might be equal to stoichiometric coefficient of reactants in a chemical reaction. But do not judge order of reaction from a chemical reaction. Okay, copy. Okay, so let's solve few questions based on this one. Determine order of reaction in the following. First, twice of N2O5 is giving 4NO2 plus O2. Rate is K N2O5. Number 2, twice of O3 is giving thrice of O2. Rate is K O3. NO2 plus CO giving NO plus CO2. Rate is NO2 power 2 CO power 0. Twice of NH3 is giving you N2 plus 3H2. Rate is K. Then 5 Br minus plus BrO3 minus plus 6H plus is giving thrice of Br2 plus thrice of H2. Rate is K Br minus BrO3 minus H plus. Solve. Itanagar, have you done that? Shillong? Done? Okay, so let's start. See, in the given chemical reactions, we have to just focus on the rate. Okay. So look at the first question. Here the power is 1, so therefore it is first order. Power is 2, second order. This is 2 plus 0, second order. Here in the question number 4, there is no reactant. So actually this was NH3 to the power 0. Okay. So this is 0 order reaction, and the last one is first order reaction. So first, second is 2, third is 2, fourth is 0, fifth is 1. Yes, these are the answers. How many of you has got the correct answers? Okay, very good. Okay, so let's practice another variety of the question. See. A plus B is giving P. Rate is K A B2. How rate of reaction will be affected on first, increasing concentration of A to twice, decreasing concentration of B by 1/3, 3, increasing concentration of A and B both to twice. Number 4, decreasing concentration of A by half. Try to attempt it. I mean, try this question. Okay. Okay. 2 more minutes for this question. Okay. Okay, so let's start. Look at this. The rate is K, A and B power 2. In the first part they are saying the concentration of A is increased to twice, means the new concentration is nothing but, I am considering it as a dash, twice of previous one, or I can say, I can write it like this. Okay, so I have to simply put these values. This is R dash new rate K 2A B square. So I can take 2 common here, I mean out of the box, K concentration A and B. So I can say that this is twice of previous rate. So it is actually increased by 2 times. Second part, it is saying concentration is decreased by 1/3. Let's say suppose the concentration of B is X. You are decreasing the value by 1/3. So can I say this one should be like this? Question was saying decreased by, not it's decreased to 1/3. Both are different statements. So this is the new concentration. Now I can put these values. So this is the new rate K A 2/3 B square. This is 4/9 A and B square. So the new rate will becomes of 4/9 times of previous one. Can I say that? Please attempt the last 2 questions as well. Now tell me the answers for the last 2 questions. Okay, so let's start. Question number 3. It is saying increase both A and B twice. So R dash will be K 2A and 2B square. So this is 8 times of K A B square. So this one will become 8 times of the previous one. Last part, decreased by half. This is A. Number 4. r dash is k a by 2 b square. So this is 1 by 2 k a and b square. Okay, clear with this one? Is there anyone who is having any doubt in this one? Okay, look at this. Concentration A, concentration B, and this is the rate. Determine order with respect to A and B. I'm solving this question. Just look at your screen. Simply copy it and then understand. Okay guys, just look at your screen. After that I'll give you question for you. See, I can say rate can be written as rate constant, concentration of A. These are reactants actually having power m, and B having power n. Okay. Now look at this. For this one, see, for this one I can frame one equation. I don't know what order is, but I can say one thing, that rate, the value of rate was 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 is equals to K. Concentration of A was Okay guys, so this one is 0.4 n. So now look at this. This one will get cancelled out, okay, and obviously this one will get cancelled out, and what can I say, that this is 1 by 2 is equals to 0.2 upon 0.4. On solving, I'll have 1 by 2 having power n. Now what should be the value of n so that LHS should becomes equals to RHS? So if I put n is equals to 1, then I can say that left hand side, the value on the left hand side would becomes equals to value on the right hand side. So I can conclude that here the order with respect to n should be the 1. Okay. Similarly, I have to pick another one, again two equations. So I'll choose this time 1 and 3. Now look at this. 1 dividing by 3. So this is 2 into 10 to the power minus 4 upon 1 into 10 to the power minus 4. Here the n will get cancelled out, k will get cancelled out, and I'll have 0.1 upon 0.2 power m, which is written as 1 by 2 power m, and this one is 2 is equals to 1 by 2 to the power m. Now again the question is, what should be the value of m so that LHS becomes equals to RHS? Now if you put m is equals to minus 1, what will happen? See, this is 1 by 2 power minus 1. On coming in numerator part, it will become 2. Okay. So the order with respect to m is minus 1. Confirm once that is it clear to everyone? Are you clear with this solution? Good. Copy please. Copy this one. Copy and then confirm. Copy this one as well. Okay, so let's move on. Question is A, B, and here we are having the rates. Determine overall order of reaction. solve this. Yes, good. 2 more minutes for this question. Those who are still trying. Okay guys, so let's start. Again we have to frame three equations. First is 2 into 10 to the power minus 3 is equals to k 0.3 power m 0.2 power n, equation number 1. Then 2 into 10 to the power minus 3 k 0.1 power m 0.2 power n, equation number 2. 8 into 10 to the power minus 3 k 0.1 power m 0.4 power n, equation number 3. So again, I have to pick equations. Okay. So first of all, I'll choose 1 and 2, because here I know that n will completely get cancelled out and rates are also equal. So on the left hand side, I'll get the 1, or right hand side, I'll get the 0.3 power m. So what should be the value of m so that it will become equals to LHS? This is not 3, 0.3, this is simply 3. Okay. So if I put m is equals to 0, we know that power of any number 0 is equals to 1. Okay. So here the value of m will comes out to be 0. Then I'll divide equation number 2 and equation number 3. On dividing equation number 2 and 3, I'll have 1 by 4 is equals to 1 by 2 power n. Simply, I can put value 2. That 2 will makes LHS and RHS equal. So overall order will be the 2, sum of m and n. And yes, the individual order with respect to A and B, it will be 0 and 2. Raise your hand those who has got the correct answers for this question. Okay, good. Those who haven't got this, please copy and then confirm. Itanagar, are you clear with this one? Very good. Clear? Okay, good. So that's all for today's session, guys. Thank you so much. I'll see you next time. Till then, take care. Bye bye. And yes, please revise it again. If you are having any doubt or queries, you can please ask me in the beginning of the class. Okay. So I'll see you tomorrow. Bye bye.